Hello and welcome to Perfect Square Trinomials, the next in our series of multiplying polynomials videos. The PST is going to be an abbreviation that we create. It's entirely ours and no one else's. It might be someone else, but it actually stands for Perfect Square Trinomial without the S. What is a perfect square trinomial? Well, it's something that follows one of these two forms, and they're really kind of tricky to recognize until you work with a bunch of them and you see what happens. So if I square a plus b, anything plus anything else, if I square that, what I do not get is a squared plus b squared. I actually asked you guys a while ago to show by counterexample that that is not true. And the way you show by counterexample is you just say, let a be equal to any number, let's pick 3, and let b be equal to another number, let's pick 5. Well, I'm plugging those in. 3 plus 5 squared, is that actually equal to 3 squared plus 5 squared? 3 plus 5 squared is 8 squared, which is 64, which is not the same as 9 plus 25. So a plus b squared is not a squared plus b squared. It is not, and it will never be. So let's kind of get away from that right now. There is no distributive property of squaring across plus or minus. In fact, the only distributive property is that of multiplication across plus or minus. That's the one that you guys have all dealt with. So given that there's no distributive property, the question then becomes, well, how do we square a plus b? We square a plus b by saying that's the same thing as a plus b times a plus b. And since it's the a plus b times a plus b, that is now going to be, pardon the emails, a squared plus, and then we're going to have plus ab, and then plus b squared. We're going to now get in the habit of combining those middle terms on the fly without writing it a second time, and going directly to a squared plus 2ab plus b squared. So that's a lot of intro for what just amounts to a few problem types. But let's do one more. We got a minus b quantity squared is equal to a minus b times a minus b. And that leads to a squared minus, you're going to have minus ab, so this is going to be minus 2ab plus b squared. Okay, I'm going to take this and I'm going to take this. And kind of up top, I would like you guys to write something squared minus 2 times the first something times the second something plus something else squared. It's kind of important that you see what's going on here. In fact, the minus here, we can make that a plus or minus, because what's happening is just, this is how you square a binomial, bottom line. Let's practice this like a gazillion times. We've got y minus 7 squared. You can write it by itself, but I'm going to show you a little trick that my Algebra 2 teacher told me my freshman year here. That trick is to, first, y squared. Then we take the negative 7 times the y, then times the 2. Now, it's not really the 2 that's here that you're multiplying by, but we like to think about it as, why not? I mean, you're multiplying by a 2, so minus 2 times negative 7 times y, that's going to be negative 14y, then plus 49. I'm going to move that. I know it drives you guys nuts when I do that, so I'm sorry. I'm going to move that down and just kind of write that out as we did it. Y squared minus 2 times 7 times y, then plus 49. That's where that came from. Okay, moving along. We've got 4k plus 5 squared. 4k squared is 16k squared. What do I mean by that? I mean 4k squared is actually 16k squared. Okay, so that's the first one. Your outer and inner are going to be 5 times 4k, so there's 2 of them. So we go plus 2 times 5 times 4k. And then last is 25. 16k squared plus 2 times 5 times 4 is 10 times 4, or 40k, plus 25. Now, another way people will do this is they'll just say, I'm misfoiling. I say, okay. You can write it next to itself, FOIL it, and have at it. You're going to get the same thing. Number 3, I'm trying to convince you of my way because it's a little faster. How do you square that? That becomes 4a squared b squared. 2 times the first times the second is, that'd be minus, because we have a minus there, minus 4abc. Then you have plus c squared. Okay, where does this middle term come from again? I know I'm repeating myself like a billion times here, but this is important. It is 2 times 2ab times c. But it is done together, and we're kind of combining it all into just one. Remember that 2 times 2ab times c is the same thing as 2 times a times b times c. That associative property of multiplication says that it doesn't matter how we group them, and the commutative property says it doesn't matter the order. So this is all the same thing as that term there. Number 4, let's kind of speed this up just a little bit more. 5c to the 4th squares to become 25c to the, c to the 4th times c to the 4th is c to the 8th. Remember, when you raise exponents to other exponents, you multiply them. Then we're going to add 2 times 5 times 2, and then the c to the 4th times d squared. 2 times 5 times 2 is 20, c to the 4th, d to the 2nd, plus, and then the last one squared is 4, d to the d squared squared is 4, d to the 4th. These are not like terms, so that's the best you can do, and let's move on. Okay, we got our first negatives in the beginning. Negative k cubed squared. Negative squared is a positive, and k cubed squared is k to the 6th. It's going to be positive k to the 6th. Then we take 2 times the first times the second. Well, that's 2 times a negative 9, which is positive 18. I always like to deal with the constants first and then worry about the variables. So then we have k cubed and n. Those are being multiplied. And then plus y plus, because a negative times a negative is a positive. 9 times 9 is 81, n to the 2nd. When we talk about descending and ascending order, here the k's are descending and the n's are ascending. Perfect. We have some solves. Okay. X minus 2 squared. This is going to be x squared minus 2 times x is 4x plus 4 minus, you guys had better be thinking giant set of parentheses here for this next part, because we got a negative in front of a quantity. And that negative in front of a quantity means that after you square it, exponents, you multiply m. After you square it, you multiply. That's following order of operations. X squared minus 2 times 3 times x minus 6x and plus 9 equals 35. Now we distribute the exponent to each of the 3 spots. X squared minus 4x plus 4 minus x squared plus 6x minus 9 equals 35. Simplify the left. Your x squareds cancel like they always seem to, at least now. Don't worry, next chapter they won't. Negative 4x plus 6 is, or 6x is 2x. 4 minus 9 is negative 5 equals 35. Add 5 to both sides. 2x is equal to 40, and x is equal to 20. Set notation because we're now solving. Got it. What I'd like you to do is pause the video, work on 7 and 8 by yourselves. Yes, I know it's going to take a little bit more time, and you're thinking, whoa, this video is only 9 minutes. This is going to be a shorty. But pause it, and then come back to me. Now you're back. Square this, don't square that, FOIL these two. First, 2n squared. Watch, we're going to do the outer and inner at the same time. Outer is going to be 3n and inner is going to be 6n. 3n plus 6n is 9n. That's the O and the I in FOIL, and then your last is 9. Equals n plus 2 quantity squared is n squared plus 2 times n is 4n, then plus a 4 because 2 squared is 4. Then plus n squared minus 10n plus 25. Simplify the left and simplify the right. N squared plus n squared is 2n. 4n minus 10n is negative 6n. 4 plus 25 is 29. The two n's drop out. We're going to add a 6n to both sides. I get 15n plus 9 is equal to 29. 15n is equal to 20. Divide both sides by 15, and you get n is equal to 20 over 15. Well, 20 over 15 is going to reduce because divide both by 5, and you get 4/3. Last one. Square the 3x plus 2. We get 9x squared plus 2 times 2 times 3 is 12x plus 4. Then we have a plus 4x squared is 16x squared. 2 times negative 3 times 4 is negative 24x. Then plus 9 equals, and this is going to be 25x squared. 2 times 1 times 5 minus 10x and plus 1. Simplify the left, you get 25x squared minus 12x plus 13 is equal to 25x squared minus 10x plus 1. You know the 25x squareds are going to drop out. You know you're going to add 10 to both sides, or 10x to both sides. You get negative 2x plus 13 is equal to 1. Subtract 13 from both sides. You get negative 2x is equal to negative 12, or x is equal to 6. If you have gotten this far and have not stopped the video, the story that I told you in class today has a little benefit. One of the things that I saw them do was something like this. 23 plus a box is equal to 31. What's in the box? The person that I was describing was struggling with this one for the same reasons that he was struggling for the other ones, but I found it interesting because what this proved is something I was trying to tell you. You guys were doing algebra back in 2nd grade, at least this kid is, because why not box? Why not 23 plus x is equal to 31? Just a little fun fact. Bye-bye.